So now we'll talk about covariance. Variance of a random variable x is the expected value of a function of x, where this function is x minus the expected value of x whole thing square. Okay, so this is variance. And now suppose I write this bracket as the product of two brackets. So that means the variance is basically expected value of x minus ex bracket multiplying itself. Now suppose I replace all the x by y. So this y minus ey and have this product. Then in this case, this expression is called the covariance of x and y. If you expand all the term, then you will get this expression. It will be the same as expected value of x, y product minus the product of expected value x times expected value y. Then we can also define something called correlation. That is the covariance divided by the variance square root of x and the square root of variance of y. Recall, variance is standard deviation square. Standard deviation is square root of variance. What is this standard deviation of x? What is this standard deviation of y? So correlation can be seen as covariance divided by the two standard deviation. Covariance can be any value between negative infinity and positive infinity. Correlation is always between -1 and +1. If x, y are independent, then their covariance and correlation are both 0, but the converse is not true. Example, so suppose I have this sample space of x and y, and these are the joint probability. So by definition, you need ex and ey. So I need ex. Ex is on x only. That means I only want the marginal probability of x. That means I should collapse y. Imagine I squeeze the table like this, so that these two become 1, these two become 1, these two become 1. I squeeze the table, so it gives me this table. Okay? So this table is basically I sum all the columns. So this gives me 0.3, this gives me 0.3, this gives me 0.4. And then with this is univariate random variable. So how do I find the ex? Value of x times the probability. So it will be 1 times 0.3 plus 2 times 0.3 plus 3 times 0.4, which give me 2.1. Now we need to find this guy. This guy is y only. That means we need marginal probability of y. We get marginal probability of y from this table by compressing along x direction. That means you can imagine I press this table towards this side. That means I sum all this number together. I sum all this number together. It gives me this table. So this table we have y1 with a chance 0.3, y equal to 2 with a chance 0.7. So the expected value of this guy will be 1 times 0.3 plus 2 times 0.7, which gives us 1.7. So now we have both ex and ey. We put the ex and ey back into the table. It will be the x minus ex, so x is 1, ex is 2.1, so we will get negative 1.1. And then x minus ex, it will be 2 minus 2.1, so negative 0.1. And 3 minus 2.1, it will be 0.9. Similarly for y, 1 minus 1.7, so negative 0.7. 2 minus 1.7, that means 0.3. So we will get this new table. We just change the x value and the y value. The probability do not change. So in this case, what does this 0.15 mean? This 0.15 in this table is the probability of x minus ex is negative 0.1 and y minus ey is negative 0.7. So this box represents the joint probability of these two particular events, and this probability is exactly what we want in computing covariance. In this case, we will have this number multiply this number times this probability, which is this term. This number multiply this number times this probability, which is the second term, and then take a sum over the whole table. It will give us the covariance. Okay? And lastly, if we divide this number by the variance square root of x and the variance square root of y, then it will give us correlation.